Welcome friends, this is Dr. Prashant Patil, Jain College of Engineering, Belagavi. Please subscribe my channel, press the bell icon so that you get the notifications, like the video, comment and share. In this video, we are going to discuss on how to find the Fourier sine and cosine transform of f of x as x between 0 to 1 and 2 minus x between 1 to 2 and 0 otherwise. Here, first of all, to find out Fourier sine transform, by the definition I will give here, by the definition of Fourier sine transform, that is Fourier sine transform of f of x is equal to fs of s is given by integration from 0 to infinity f of x into sine sx into dx. Okay, then my f of x is defined between three types: 0 to 1, 1 to 2 and for 2 greater than 0. That's why this integration will divide it into three parts as fs of s is equal to integration from 0 to 1, next integration from 1 to 2, and another one is integration from 1 to infinity. This 0 to infinity I will divide into three parts. For 0 to 1, my f of x is defined to be x into sine sx dx, and 1 to 2 function is 2 minus x into sine sx dx. Whereas from 1 to infinity, more than 1, the function is defined to be 0 into sine sx dx. Okay, therefore for this term totally it will become 0. These two I have to integrate using the Bernoulli's rule, that is x into sine sx. I will consider x as my first function. X into integration of sine sx will become minus cos sx divided by s, and minus differential of x is 1. Integration of minus cos sx divided by s is nothing but minus sine sx divided by s square. This is between the limits 0 to 1. This is the integration of first term, x into sine sx. Like that, 2 minus x into sine sx integration. Here also Bernoulli's rule only will use, that is I will here take here. Then next term is 2 minus x as my first function. Integration of sine sx is minus cos sx divided by s, minus differentiation of 2 minus x 0 minus 1 into integration of minus cos sx will become minus sine sx divided by s square, and this is between the limits 1 to infinity here. Okay, now I have to substitute the limits, upper limit and lower limit, and to evaluate. For upper limit, x is equal to 1 first, that is minus cos s, x equal to 1, therefore minus cos s divided by s, minus of minus plus sine s divided by s square. This is for upper limit for n x equal to 1. Now for x equal to 0, lower limit x equal to 0 minus x equal to 0, first term will become 0, second term sine 0 is again 0, minus 0. Okay, like that. For here 1 to 2 it is now plus upper limit x equal to 2 first. For x equal to 2, 2 minus 2 into minus cos 2s divided by s, minus 3 times minus, therefore it will become minus only sine of 2s divided by s square. This is for upper limit, but anyhow 2 minus 2 it will become 0. For x equal to 1 now, next minus, for x equal to 1, 2 minus 1 into minus cos s divided by s, correct? S x equal to 1 minus 3 times minus, again will remain minus sine s divided by s square. Okay, now simplify this one. What I'm going to get here is minus cos s divided by s plus sin s divided by s square. One term, this is minus, this is 0, and here it is minus sin 2s divided by s square. And what about this one here? 2 minus 1 is 1, minus and minus, plus we'll get cos s divided by s. I'm going to get, and then this is anyhow next minus of minus plus sin s divided by s square. Okay, but here minus cos s by s plus cos s by s cancels, and from the remaining three terms, what I can take common here? S square, 1 by s square I can take common, and I can write it as sin s plus sin s, 2 sin s. Okay, 2 times sin s into minus sin 2s. Correct? I can further, I will solve here, that is 1 by s square into 2 sin s minus sin 2s can be done as 2 sin s into cos s, and from these two I can take again 2 sin s common divided by s square as it is into 1 minus cos s. Correct? 1 minus cos s can be written as 2 sin s divided by s square into 1 minus cos s can be done as 2 times sin square s by 2. Okay, and this one I can adjust and write it as fs of s is equal to sin s into sin square s by 2 whole divided by 2 into 2 4. I will take it as s divided by 2 the whole square I can write. This is the required Fourier sine transform. Like that, I will going to find the Fourier cosine transform here. By the definition of Fourier cosine transform, fc of f of x is equal to capital Fc of s is given by integration from 0 to infinity f of x into cos sx dx. Okay, but this f of x is defined in 3 different ways. That is, I will split this 0 to infinity into 3 types. That is, fc of s is equal to integration from 0 to 1, next integration from 1 to 2, and integration from 1 to infinity. For 0 to 1, f of x is defined to be x here, x into cos sx dx, and from 1 to infinity it is 2 minus x into cos sx dx. Whereas 1 to infinity function is defined to be 0 into cos sx dx. But 0 into anything will become 0. This integration will become 0. These two integrations I have to evaluate. To integrate these two integrations, first I will apply the Bernoulli's rule for that. That is, first term as it is, integration of cos sx will become sin sx divided by s, minus differential of x is 1, integration of sin sx divided by s is minus cos sx divided by s square. This is integration of x cos sx between the limits 0 to 1, plus integration of this one is nothing but 2 minus x into sin sx divided by s, integration of cos sx, plus minus differential of 2 minus x will become 0 minus 1 into integration of sin sx is nothing but minus cos sx divided by s square. This is between the limits 1 to 2. Now I have to substitute upper limit and lower limit for both the integrals. That is, for upper limit x equal to 1 first, 1 into sin s divided by s minus of minus plus 1 s equal to 1, the x equal to 1, therefore cos s divided by s square. Upper limit minus lower limit x equal to 0, 0 into anything will become 0, minus of minus plus cos sx, cos 0. Cos 0 is 1 divided by s square. Correct? Then plus, next again upper limit x equal to 2. 2 minus 2 into sine 2s divided by s. This is upper limit. Plus, minus, minus, minus. Again minus 3 times. You will get cos 2s divided by s square. Upper limit minus lower limit x equal to 1. 2 minus 1 into sine s divided by s minus 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 3 times. Therefore again minus. And x equal to 1. That is cos s divided by s square. Let me simplify them. That is, I am going to get it as sin s divided by s for first term. Next, plus cos s divided by s square and minus 1 by s square here. Here 2 minus 2, it will become 0. Okay, then it will become minus cos 2s divided by s square. And what about this? Minus 1 minus sin s divided by s, minus of minus plus cos s divided by s square. Okay, now what you can do here is sin s divided by s, plus and minus, they will cancel, and from the remaining terms, what I can take common here? Okay, I can take common 1 by s square common. If I am taking 1 by s square common, then we will remain with cos s, 2 cos s minus 1 and minus cos of 2s. This is okay. This can be further simplified as, what I will do here is 1 by s square into 2 cos s minus, I will take common and will remain with 1 plus cos 2s. And this 1 plus cos 2s can be replaced by 2 cos s as it is, minus 1 plus cos 2s can be replaced by formula, that is 2 times cos square s. Okay, and from these two, 2 cos s can be taken common. After taking 2 cos x common, we will remain with 1 minus cos s. But again 1 minus cos s in half angles, 2 cos s divided by s square is 2 times sine square s by 2, and this can be adjusted as fc of s, Fourier cosine transform, is equal to cos s into sine square s by 2 whole divided by s square divided by 4, that is s by 2 the whole square I can write. This is a Fourier cosine transform. Like this, some more examples on Fourier transform I am going to solve in my next videos. If you not yet subscribed my channel, please subscribe the channel. Don't forget to hit the bell icon so that you will get the notifications of my next videos. Like this video, comment and also share this video. Thank you friends.